Talk about some fucking chemistry, goddammit. Alien life, Fermi paradox. What else we got? We got a lot of good shit we're going to be talking about. Hopefully, Dr. Cronin shows up here soon. We're going to be talking about digital chemistry. We're going to be talking about assembly theory, self-assembly, nanoscience, systems chemistry, inorganic biology. A lot of cool shit that we're going to cover with our friend here. Hopefully he doesn't have trouble signing in. Hello to everyone who's joining the room. How are you? Everyone excited for Dr. Lee Cronin? I am. Again, to everybody just joining, we're going to be covering a lot of chemistry. We're going to be covering a lot about life. I'm sure abiogenesis and all kinds of topics might come up. I don't know how long we have Dr. Cronin for, but I shall ask him when he gets in here. Why are you such a cynic, Trav? Answer me that. Because my butt. Yeah, that's true. Does anybody have any good questions? Put them in the text real quick for me if they've got any questions I want to ask them. Remember, let's try to stay on chemistry and life and biology and stuff like that. Let's try to stay on topic. No smuggling in politics today, goddammit. Or religion. Keep that shit at the door. We'll do that another night. Politics and religion. Chemistry and science. Double thumbs up. Travis, did Brady come to the room last time? You want me to keep an eye out for that? Hello, welcome everybody for just joining. If you're coming straight in, we're waiting on Dr. Lee Cronin to show up so we can start the fun. Thank you everybody for coming to hang out with me. I love it, and I love you. Anybody who has just joined, if you have any questions that you want me to ask Dr. Lee, please post them in the chat, and I will scroll back through and get to them. Like I said, anything with biology, life, aliens, any of that kind of stuff, Dr. Lee's in that shit. He knows a lot about it. The building blocks of life, he knows a lot about that kind of shit. And of course, chemistry is not my thing. I'm a psychology nerd, so I'm out of my element here, but I love it because it allows me to learn something that is out of my element. And most of the time I do lots of study and research for the person that I want to talk to. But this time I'll tell him when he gets on here, I'm just freewheeling it, seeing what I can learn just from a casual dialectic. Oh, sweet. We got 14 people in here. Awesome. I don't have any pre-material to cover to keep everybody entertained. Anybody want to come up and talk to me? Scott, you here? Scottimus Prime? You son of a bitch. There you go. Aaron's gonna talk to me. What's up, Aaron? Aaron. Hello. Anybody here?
Can you hear me?
Yeah. Can you hear me?
I can hear you fine.
Okay. Cool.
So I was just having a conversation about this yesterday in the Discord.
Okay.
Um, to
Real quick,
me,
Aaron. Real quick, Aaron. As soon as the Dr. Lee shows up, if I cut you off in the middle of his,
that's
I'm
fine. I
sorry. I
get it.
just have.
It's
Yeah.
fine.
Yeah. 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 Okay.
I get
Okay.
it. But if I had to pose a question to someone who deals with life and biology, I think that question would be, what really is the likelihood that there is life that isn't carbon based?
Yeah.
Because I think a lot of what we're trying to do as a species right now is we're basically trying to look for other carbon based life forms. And I am genuinely curious
What
to
about
know
silicate life, Aaron? You know what
exactly,
I'm talking about? Yeah.
exactly. That's what
Yeah.
I
Yeah.
want to
Yeah.
know because maybe life takes on more forms than what we're used to.
Oh yeah.
Or
Like we could be looking at a planet right now, like an exoplanet or something, and it could have life on it, but we don't know how to detect that kind of life. You know what I mean?
and we don't know what it would look like.
Exactly.
So that would be that would be my question.
Oh, we got
What's
we got
special?
Dr. Lee, Aaron.
Okay,
I will ask him. Pop back down,
all right.
and let's get Dr. Lee in here. Dr. Lee, I invite. There you go. Excellent. And then there's a little video button and a mute button on the bottom center of the page down there.
Okay, you can hear me. I can see you.
Yes, I can. What's up, man?
Yeah, all right. I just had to follow the instructions. Sometimes that's
This is a brand new uh, system. This call in, so it's kind of buggy. It's in beta. You know, just be patient with us because
it worked
it
so
has
far.
been
I mean, there were some instructions. I followed them. It worked. That's good.
nice. My name's Thomas. Would you like me to call you Lee or Dr. Cronin or what works
Lee's
for you?
fine.
Lee? Okay.
Yeah.
Well, I'm Thomas Lee. I'm so happy to have you here, man. When Felicia told us that you were coming, I was like, oh, this is going to be a great one. So my area of expertise is in psychology and philosophy, so a lot of this stuff is new to me, and learning. You know, when I interviewed Donald Hoffman and a couple of other people like Dr. Christopher Mason, I don't know if you know who that is, but he's a
Mhm.
genomics expert. He worked with the ISS. I did a lot of study before I talked to them. With you, I just kind of wanted to just kind of have a dialectic. You know what I mean? Just
Mhm.
not pre-study you or anything, and just kind of learn what you're about.
Okay, no problem.
Yeah. So I do know that you're interested in life. Obviously, I saw that. I watched your TED talk. But what is it that you're truly interested in? What do you love?
What do I love? Existence. I want to know why I exist, and beyond the birds and the bees, understanding what is the physical properties of the universe that allows life to exist, and what of those properties have we not currently captured in our current understanding of science, and how can we exploit that technologically to affect the rest of the universe with more life? So yeah, just the small things.
Yes. Um, you know, all these fields that I looked at you know, being a part of, um, like I know nothing of nanoscience, or I also wanted to ask you about assembly theory, and we'll get into that in a little bit, I'm sure.
Mhm.
But like systems chemistry, these things I don't know too much about. And what do you mainly deal with? What is your main area of operation at the university you work at?
Yeah, so I'm a university professor and also CEO of a company. So that's
Oh,
kind of
nice.
interesting doing that at the same time. But I'm
Hmm.
a chemist by training, so my degree and my PhD are in chemistry. But
Mhm.
as long as I can remember, I've always been doing that at the interfaces of mathematics and computer science, robotics and engineering,
Mm.
and some biology, and quite a lot of biology, but not as some people see it. And in the last few years, I've been combining robotics and chemistry and artificial intelligence and big data, if you like, to try and understand how we can build um, robotic systems to do chemistry, to make new drugs, discover new drugs, manufacture stuff, and also make like a massive experiment, almost like the Large Hadron Collider, for
Oh,
the origin of life, and to try and understand how life emerged on Earth. And I don't think it's actually that hard. I'm a chemist. That's the main thing.
yeah.
I do robotics, simple robotics, I would say, and fairly reasonable software engineering and electrical engineering and mechanical engineering to get the chemistry to the right place. It really needed a chemist to design all that, because lots of roboticists are always scared in the lab of chemistry, right? You could do something, could be unsafe, could catch fire, could explode, could generate
Right.
but also chemists are afraid, used to be classically afraid to code. Obviously, the barrier to coding is now getting lower and lower, but it's kind of that interface which I think is where I'm working at mostly. But I mean,
Okay.
I go wherever the problem is.
And Pangburn I all that is extremely cool as hell. We'll get more into it, but Pangburn literally asked what I was going to get into because you talked about life as your existence, abiogenesis. What do you think?
So, I mean, the problem of abiogenesis right now is we just think about it as a singular event that work happened on Earth. But one of the things I'd like to kind of draw attention to, I mean, this is probably not easy to see, but when you look up in the sky, or every day or two, a star is born in the universe and then the star dies, right? So it's a
Right.
real time phenomena. And
Yeah.
so I think it's also reasonable to speculate that every day or so a new origin of life event occurs in the universe, and another life, maybe another planet used to have life on it, has come to an end or something. So you think
Does
of it as
does it necessarily have to be in the Goldilocks zone?
no, I mean the Goldilocks zone is very locked to us, right? So I think
Yeah.
the Goldilocks zone is generally a nonsense, but for other aliens, but for us, it's super important. If we want
Right.
to be able to go and survive somewhere, then a Goldilocks zone, I would like a nice planet, one atmosphere, 20 degrees C,
Yeah.
um, you know, um, a good level of oxygen, nothing toxic. So a Goldilocks zone for life as we know it is absolutely vital. A Goldilocks zone for alien life is unknowable
Yeah.
until we know alien life.
Yeah. I mean, we could have silicate life out there, like we were talking about earlier with Aaron. Um, what other forms of life? Well, I don't want to get too far. We'll talk about it in a second. So abiogenesis. What do you think? And I'm not an expert. But what do you think is actually going on there? What do you think these self-replicating molecules? Like, you have a good idea, a much better grasp of it than anybody here, of course. But
Um, so so look, we don't know an awful large number of things, which is super interesting, right? That means we have a job. I have a job, and for a few years. So I think there's we don't know the physical process that gives rise to life. So let me put that in context. The thing about the sun, what happened at the origin of the sun? Well, a load of hydrogen got together, and at some point, hydrogen went under ignition and generated a stable fusion process. And I guess at the birth of the sun, some things happened to create that process. But what was the driving force that made the sun? Gravity. So
yes,
gravity, so as mass accreted and went closer, got in, you had this increasing density and this rapid increase until the gravitational force at the center of the sun was able to overcome the strong nuclear force.
right, yeah. Inside pushing out, outside pushing in. Yeah,
Exactly, and then you get detonation. So I think what we have to do is to say, well, what is the force, if you like, that gives rise to life in general, and how does that operate in a chemical world, rather than thinking about molecules, self-replication, genes, proteins, all that stuff. It's really very, very simple question, which is simple as the driving force. Now we know once life was established, there was this thing called Darwinian evolution. But
Yeah.
what was the force, or if you like, or the process, the mechanism which brought inanimate matter to life, literally brings it to life? And that, I think, is the question. And so I'm very careful to try and reframe that question in a more general sense. And one of the things a lot of chemists that work in the area are not really framing the question because they're not really equipped to do the scientific philosophy required, because they're doing chemistry, and I'm trying to bridge that gap to be helpful.
That's awesome. That's what I want to happen. Um, so let's go. That's that's perfect explanation. Let's go back into the Goldilocks zone stuff. So I love the Fermi paradox, obviously, and I know you have probably delved way deep into it. Um, so this silicate life or this other type of life, if we're looking at the Drake equation, what do you think about how many in our galaxy? What could you think about that?
The Drake equation. I mean, the Drake equation really is a kind of cultural equation bitten by Drake, right? To say the fraction of, let's take all the stars in the universe and what fraction of the stars are capable of having life, and which ones actually have life, which ones have currently got tech technology on, and what fraction, and what is the timescale for all of these. And
Yeah.
so, because we don't know any of those numbers, except we probably know the number of viable planets out there might be almost as equal, or if not slightly higher than the number of stars, which is
Yeah.
kind of astounding. But the Fermi paradox, I think, is a failure of imagination. Um,
Okay.
it's not. I think that's probably a problem that a lot of people have not
So
really.
you don't think the great filter is something that we have to worry about?
The great filter is merely our inability to understand how diverse alien life could be. There might be a great.
Oh, okay.
Yeah, yeah. So we have to. I mean, it's really very. It's very tricky. I mean, if you think, imagine. I don't know if anyone you have cats, right? I have
Oh,
cats.
I have two cats.
All right. So look. So you've got your cat. Your cat doesn't actually really recognize your face. They recognize your smell, recognize you. Don't recognize a name, but the cat recognizes fast little movements because it was evolved to get rodents, right? So the cat is perfectly programmed to get a rodent. But if you had a big elephant wandering around in your yard, the cat would never see the elephant. They'd just be like, wouldn't see it because they
Yeah.
have evolution. Although they've got eyesight, and they don't have enough cognitive capacity to ask questions. They are merely trained to their eyesight, and what cognitive capacity they have is really aiming at getting these rodents, and that's it. And I wonder if the fact that because we've evolved on Earth and we've got, we see in the visible, we hear sound waves in one atmosphere and a certain frequency range, we're able to detect heat in a certain range and feel vibrations and all that stuff. That
Yeah.
And although we can use scientific instruments to help us work out when things are changing, but because of the way our priors are, that I think the Fermi paradox is actually, we haven't yet worked out what life is, and we haven't worked out what intelligence is, and we haven't worked out what a universal communication system would look like. Now, Carl Sagan and a few philosophers had a really good go. Say if we find prime numbers being beamed at us at high energy, then prime numbers, are probably not easy to produce naturally, although I might have something to say about that in 6 months. I can't reveal
Okay.
much right now, but I'm playing around with an idea. So I think the Fermi paradox is really, and perhaps I'm being caught slightly unfair to Fermi himself in that, to say it's a failure of imagination, because obviously it was a different time then. But I think the science fiction writers of the time, we should be the people that thought about it, like Stanislav Lem, Isaac Asimov, people like that. So
Yeah.
that I think is a. So I think the Fermi paradox is not a paradox. What's a paradox is that aliens are going to be so different to alien biology is going to be so different to Earth biology it is unlikely that we are going to be recognizing very easily. And we do have the speed of light to contend with.
Yeah. I mean, we anthropomorphize life. I see most of us tending to anthropomorphize life outside of Earth. Um,
Exactly. Well, and you can't blame us. We don't know anything else, right?
yeah, exactly.
It's not as if we grow up in an alien academy. We grow up in this on this planet in this gravity well. It's. I have total sympathy for it, but I think that we there is a chance there is no life in the universe, and we're it, which I think is fascinating. But I also think there's probably a larger chance there's a shit ton of life in the universe,
Yeah.
and
Yes.
a lot of it is probably boring.
Yeah.
But we just don't know. We just don't know. It's one of those.
Could there be other humans out there since we had a star explode and all that happened? Could there be other humans out there?
Well, I think there won't be other humans as in identical to us because I think it's very. We've almost proven in my laboratory and with my collaborators that the features that you have associated with life on Earth are absolutely unique to Earth and unique to the history of Earth. The size of the Earth, the precise size, the amount of water, the amount when the dinosaurs got killed and all that. But if you imagine you look for our Goldilocks zones or other stars and look for planets with similar composition and look for planets who have a simpler gravitational force and atmosphere and temperature, if the process of evolution was to run again on those planets, I would expect to see very similar types of life forms. Probably the chemistry would be different, but it wouldn't be outrageously different,
Well,
right?
the periodic table of elements would be the same for that planet, right? We assume.
Yeah, so yeah, sure. So the periodic table is it's reasonable at this point to suggest that the periodic table is universal table of elements. We understand in physics. It might be that on some planets the the precise percentages, the abundances of the elements will be slightly different, and that might affect how life has formed. But in general, if you the way to do it would be to look for similar worlds to us, similar distance from the star, similar property, similar amount of water and ability to hold on to an atmosphere, and then I think life on those planets would be remarkably similar and remarkably
Yeah.
different. Remarkably similar in that there's only one or two ways to solve the problem of moving around on a rocky planet, but remarkably different in that the chemistry will be different. There might be different universal solutions to
Yeah.
universal, as in on the planet, not universal.
Yeah.
So whatever technology got going first on the other planet might dominate it. So right now on Earth, the technology or the evolved machinery that we have in biology is highly conserved. So there's this engine called the ribosome, which converts DNA. Well, DNA gets converted to RNA, and then RNA and amino acids come together to make proteins and help the cell work. That machine is in every single cell on planet Earth without
Yeah.
exception. So
Yeah.
that machine is the big filter for our biology, and what it will be on other planets we don't know.
Yeah. And that's what I was thinking. Like, with oh, and by the way, everybody, we'll be taking callers here in just a little bit. Um, so you do though think that there will be other, and I understand you completely. There are other conscious agents out there. Would you say that that might be the case, or is the case?
I don't know if there's actual conscious agents out there because I don't know if consciousness is particularly a special property. I
Okay,
mean,
so maybe just intelligence then. You know what I mean?
yeah, I mean, I think intelligence probably intelligence requires consciousness in some degree because consciousness allows you to
Okay.
basically how build abstractions. But I
Well,
mean,
the way I look at it is like consciousness is the overarching like category, and then intelligence is a epiphenomenon of consciousness. Something like that.
yeah, but I would probably put it the other way around because crows display intelligence much more intelligence than they do consciousness.
Oh
Well,
yeah, yeah, I could agree with
Well,
that. Yeah,
I don't know. I mean, of course, all the panpsychists and Donald Hoffman and all these guys kind of
yeah.
like to try us how consciousness is the universe.
I
But
I talked to Donald Hoffman for 2.5 hours, and it was interesting. I mean, I love his ideas, but He is fringe, you know.
No, I know, but I think he's not fringe. I think he's not just fringe. I think he is pulling strings on in the metaphysical strings to gather following, and when pushed, he doesn't really back it up. He just talks nonsense, and I don't like that.
Some of the stuff that he told me, I was like, I understand that you're an empirical person and you want to bring these things like, you know, this consciousness monism back into the empirical and try, but you know, a lot of it I don't know. You know what I mean? I'm open, but he's one of the most interesting people I've ever talked to, you know,
Oh, he's
including you. And yeah,
certainly
he
interesting,
is.
but I'd like to hold him down a bit and say like I don't. So I think that if you're going to have these ideas, you need to be willing to explain them and falsify them. Okay, and then evoking kind of nonsensical, mystical, stuff that
Panpsychism, yeah.
escapes proper study really doesn't feel to me to be it's very it evokes a certain superiority. It evokes a certain kind of arrogance, and also it evokes a kind of narcissism. These are not
Mm.
traits that you want if you're looking at the universe, as I kind of tried to say to Eric Weinstein once, but that didn't go that
No,
well.
I agree with that. I think your way is the right way to look at it. No, I mean Donald Hoffman, he has I I know exactly what you mean.
He needs
So,
it needs to be done in an experiment, right? There needs to be some kind of falsification.
well, that's what I was going to say is that he
Yeah.
told me that he has, you know, he has done these experiments and that Yale is responding to him. And I asked him if he would send me that response
What does it
when they
mean
send it.
responding to him? What does that actually mean? Well, what is this?
Well, I don't. He didn't get too deeply into it. Is that he did some experiment that showed that um, I guess certain, you know, I'm not an expert in this, but certain self-replicating molecules or whatever nucleotide. I can't remember what he said, man. I'm sorry.
Yeah,
Um, he said that that life is not programmed to show us what is true, but to show us what is the best pragmatic user interfaces, and that's why he says these user interfaces and data structures might be some form of consciousness is the
yeah,
fundamental
but that's
instead of
nonsense. When
space time.
a data structure is formed in an abstraction. When
Yeah.
people start saying that a data structure is the fundamental fabric of the universe, they're Looney Tunes. Same with Stephen Wolfram, right? And the universe is not mathematics. Mathematics is a method we have developed to describe physical
Yes.
reality. And so when
Yes.
you mix those realities up and you go woo woo, then you're like, well, okay, fine. You can just make
I'm
anything
with
up.
you. I'm going to stay on the empirical, and I'm going to say on what we can observe and hypothesize
We
and
can go
test and falsify.
We
You
could
know.
go metaphysical as well, but metaphysical with a relationship to the empirical. It's what I'm saying, which I think is I'm trying to be very precise on, is that there are a category of thinkers out there that aren't thinkers. They are preachers in the same way you could go to an evangelical church or something, and there's nothing wrong with that, right? If someone says, "Okay, I'm a religious person. I believe in this religion. I have this belief system." And that's great. We all have belief systems, right? Some have less belief systems than others. But when people try to pitch and sell their belief system as an empirical system, and then when you challenge it, just make up nonsense about you not being able to understand the data structure or the user interface, I just have one big bullshit detector that goes off in my head and says, you know, it's bullshit.
The woo woo is too much.
It's just bullshit. It's just bullshit. And
Yeah.
and like I am about, I'm probably the biggest empirical fantasist there can be without being woo woo, right? Because
Right. Yeah.
if you try and go too far off the and maybe Elon Musk is as well, right? I mean, he's
Right.
building the big FR, right? And the BFR is just like an epic, borderline technologically possible marvel, which might lift off in the next 2 months. And so you have to have some kind of fantastical vision, but then reality has to bring you back to that. So user interface,
Yes.
data structures, nonsense. The only user interface we have is the ones that we put on on computers or now in our
Yes.
technology. The only data structures we have are the ones we build ourselves. The universe doesn't have a data structure, and when people talk with authority and use those words, it is patronizing to others and actually not very helpful.
He is extremely sure of himself about his ideas, and I understand what you mean
I
entirely
have no
by that.
clue what I'm doing, and I love it.
Yeah. I mean, I know that I don't know, but uh, so Wolfram, you don't think that everything can be like computational, to this infinite Turing machine that he talks about?
No, no. Wolfram is extremely frustrating, and he's incredibly smart and
He is.
incredibly close on some things. But
He is.
his ego and his prevents him from adequately cooperating with others and really, in the scientific community. But I kind of like interacting with him. I've only spoken to him on a handful of occasions. It's
Yeah.
quite difficult to get through to him because it's all about him. And so and I guess it's all about everybody. It's all about them. But I think it would be good to have an exchange. So what Wolfram kind of says is the universe is a cellular, something like a graph that gets updated and that produces reality.
Cellular automata and all that. Yeah.
But it's the problem is the cellular automata the only cellular automatas we know have to exist in a silicon substrate. There is no machinery that updates the universe. So again, I'm happy if Wolfram said, "Hey, I've got this description of the universe," but the description he has of the universe, of course, is interesting because I'm going to use an annoying word. It's isomorphic with the
Yes.
other descriptions of the universe, which means that's a fancy way of saying it's mathematically identical to the
Yeah.
others. But it's really kind of like not practical. So it's like, oh, we just derived general relativity from our description of the universe, but we needed like a gigaton of calculations to prove it for real. Like, yeah, that just means your descriptions are really bad, right? It's really slow.
I
You
see
know,
what you mean. He's I would like to get to talk to him, but I see what you mean that he's kind of stuck in his own world, because every interview or talk I've ever seen with him is, he's like, well, we don't throw out quantum mechanics, but this and but that, but it's all about his um always going back to this computational universe ideology. You know what I mean? It's about that no matter what kind of thing when you listen to
so
him.
you're right. It's an ideology. So look, I mean, don't get me wrong. I have an ego as well, right? I mean,
Oh yeah, me too.
I like to,
Yeah.
but what I think is super useful in the situations, and I hope to get somewhere deeper by doing the following: coming up with an outrageous idea and obviously pushing it. Making it all about Cronin, the Croninites, Cronin mathematics, whatever. Talking to my peers. My peers say, that's wrong. That is not consistent. Da, 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 da. And at the end of the day, you've done this thing. Why should I engage with it? What does it do? And I think if we can generate new understandings that allows you to design new experiments, that allow you to uncover, that then make new predictions you couldn't make before. If I create a toolkit that's useful, and so maybe a toolkit for you when you're interviewing others, talking to others, is to say, okay, to Donald Hoffman, tell me what is the toolkit you've developed and how might I use it and how might it tell
He
me
didn't
that,
tell me that.
yeah, of course. And same for Stephen, same for anyone, say, what is the toolkit? And I think, and also, most toolkits aren't finished, right? So the toolkit for measuring life is assembly theory, but at least I could tell you what to do tomorrow with assembly theory, and it would give you some new results,
Yeah.
and allow you to make a slightly different kind of
Better
experiment.
data. Yeah.
So that's kind of important. But having said that, if I haven't talked to Donald actually, and I'm not sure if I would like to talk to him or not, because I might find it frustrating because he might just not answer the question. But if he wants to have a conversation in good faith, then I think it could be really interesting and productive.
I would love to host that. You're always welcome to come back. I really enjoy talking to you. You and him are always welcome to come at the same time and have a discussion with me and Travis. We would love that. Travis actually in the chat says we will set these up if you want to. So just let
Well,
us know.
let's see. Let's do this one first.
No, I'm enjoying the hell out of myself because this is what I love to talk about, and I don't mind talking about other scientific views like Hoffman and all this kind of stuff. And I know what you mean. Like it can almost seem like Deepak Chopra You know what I mean? In some ways.
Yeah. I mean, it's deeper. I mean, I just don't. Everyone when people was trying to sell stuff, and to some degree, we're all selling stuff, right? Even I'm like, I'll tell you about my computer and all that stuff and why it's wonderful, and we're all trying to sell stuff. But I think at the end of the day, um, when it's this kind of obviously it's not just in the American psyche, but obviously in the UK, a lot of people want to. There are cultural elements you can pull on, and then you can exploit people. So if you kind of manipulate people, you can enchant. So if you go to see an illusionist, you're paying to see an illusionist or a magician. You know you're about to be manipulated, right? Because they're gonna confuse you, or make
Yeah.
you look at focus on one aspect and then do this trick where you'll go, wow, that's interesting. Whereas if you go to someone who says in good faith, I'm going to do X, and actually I'm doing Y, or I'm doing this in bad faith, just try and extract money or make you feel, vulnerable, mystical, whatnot. It's hard, you know. I guess it's freedom for that. I mean, you have that in the US more than anywhere else. Freedom for delusion.
You're
I'm
right
not.
about that. Oh my God, that's a good quote right there.
I'm not sure if it's a good thing, but yeah. But the thing is, the reason why I do things like this, I'm very happy to have these conversations. It's super important to um, treat people with respect and and give them afford them the intelligence that they deserve, right?
I
So
agree. Yeah,
and if people if and I'm an absolute believer if that more people in the world could think critically, then we would have and we will. It's increasing. The number of people thinking critically is going up. It's not going down.
I
Um,
agree.
and there are polarizations we have to overcome. Like in the U.S. Political system, you have quite dramatic polarizations, right? Where
Yes.
the Republicans came out and said, I don't know, let's say they hate. Let's do two equal ones to be equal. So let's say the Republicans say they hate tracing paper, and the Democrats love colored paper, right? You can imagine and let's just say there's some Republicans that use colored paper for a living, right? They would immediately give up colored paper, even though it made no sense because of their political ideology. And the Democrats using tracing paper would give it up because of their ideology without any critical thinking. And you're like, got these two guys like tracing paper and colored paper. Yes, look at these guys. How dare you? So it's kind of like, and you saw this during the COVID-19 pandemic, where
Yeah.
you know where it kind of falsely, I would say, the left wing were shown as being sensible, wearing face masks, and the right wing was seen to be kind of right wing, kind of
Yeah.
totalitarian. I'm not wearing a face mask, f you type thing, which is
Yes.
actually not true, right? It's just like, I don't want to be told what to do. Right? I wore face masks, but when people told me what to do in this kind of very vigorous way, it made me not feel in control, and I've already been told to stay inside. But if someone said, "Oh, please consider doing this and doing that. It'll be good." Much more compliance, much more doing it, and so I think there was always this grey area, right? So we have to overcome that in critical thinking. Whether we're pan
I
side.
think that's the key. The critical thinking and the gaining of wisdom and knowledge. I think that's the key.
Yeah. And I think it's fun to have arguments, right?
Yeah.
If we look at it, when I was looking what was going on in the pandemic, I was actually pretty. I know everyone's like, all the epidemiologists must have like been like, yeah, this is it. We can. If you're a woke epidemiologist, you're in it for years, right? Because you can
Yeah,
say how
lots of
bad
money
it
was
is.
thrown at epidemiologists and virologists and all these people
Yeah,
doing
yeah,
their
yeah.
job.
And I would say, look, I'm actually pretty. I mean, maybe people will tell me, I'll say I was pretty. I'm inspired by the way the planet responded. We did respond quite well. We did lock down. We did try and accept kind of different ways of doing it. And I think actually the one that looked kind of oddest to me was the way that China kind of all started in China, but China locked up, kept locked up for longer,
Yeah.
didn't take the best technology, waited
Yeah.
until the Congress was done, and then basically went, "Oh fuck it, you can all get
Yeah.
COVID now." And like there's like 1.4 billion people had COVID last month.
Yeah.
I mean, 1.4 billion people. and there will
Yeah.
be a series of 3 or 4 waves. Now, arguably, China did a good thing in waiting for a bit because people's immunity, getting vaccines out there, but did they take it? So, and it was kind of the way that the West were like, the China was, lots of people in China were like looking at the West saying, "Huh, you guys are terrible. Look at what we're doing," and then they've been
Yeah.
locked down for such a long time, and there's this polarization and again. Total lockdown, no lockdown. No. We just have to find a way that works. Anyway, I don't know how we got from origin of life to lockdown.
No, you're fine. This is what this is about. This is an informal tangent session, and I'm fucking loving it. Um, uh, we're gonna take some call. Let me look down real quick. I don't think we have any callers just yet, but let's talk about, since I'm selfish and I want to know, let's talk about assembly theory. Can you teach a simpleton?
Yeah, so assembly theory is super easy. It helps us work out whether something has been made with information that was created by some. So yeah, let's use information, whatever that is. So we'll come to the definition of that. And the way that works is like it's very agnostic, which means it's very broadly applied. So assembly theory says if you find an object somewhere with more than several copies, let's say I don't know what your favorite kind of, if you support some clubs for sports or
Yeah,
basketball, American football or something, but whatever.
sure.
Take their flag or their kit, and you find on Mars one example. You'd be like, "That's weird. That looks identical to something on Earth." But you find that 2 or 3 of them, and it's really complicated. You'd be like, "Whoa, this could not have formed by chance." So what
Right.
assembly theory says is, if I find an object in my backyard, on Mars, wherever, and I find many copies of this object, and this object can be broken into many different dissimilar parts, it has low symmetry, then
Okay.
it's alien or evolved, right? So if it's on Mars, it would be alien because life,
Yeah.
the Earth
No
isn't.
right angles or spheres in nature, kind of
Yeah,
thing, right?
so assembly theory literally tells you about how difficult it is to make that object in the absence of a natural process. So perhaps the simplest thing to think about would be or the most complex thing to think about is you went to Mars and you found a pile of sand and you found 100 piles of sand and they all looked identical. You would say, oh, that's not very complicated, it's just a pile of sand. But then if you went to the end of all the piles of sand and you actually found there was a big grinder there and it was actually grinding up Apple iPhones into sand and splitting them out, and you managed to stop the grinder and you looked and you saw 1,000 Apple iPhones on Mars, you'd be like, oh, assembly theory would tell you that these iPhones couldn't have appeared by chance and they must have been created by an informational process. So
Okay.
now let me give you a really simple way of looking at it. If you go to a keyboard and you just randomly type letters, you're like, so that's fine. Let's say you type abracadabra or banana. If you type abracadabra is actually quite a hard thing to type. It's not that many letters, but there's also some repeats in it. So rather than the 11 unique letters or the 11 unique letters in the sequence, you could actually
Yeah.
have 7 plus 4, right? Because there's a repeat unit. So
Yes.
what assembly theory says is take the object, break it into parts, remove all the repeat units, add it into and then put it into your little manual, and then count the shortest number of steps you need to take to make the object with your units. And if the shortest number of steps is above a threshold, then you can be sure that it wasn't made by chance. Now, a
Right.
better way
That
of
it
looking at
wasn't
that,
natural. Yeah.
yeah, it's a better way of looking at that. So we were talking making sure it's super understandable. So I think what I've said is assembly theory looks for complexity. That's number one. Does the object have lots of different parts? Number two, can you find more than one object? Because if you just, I don't know, if you spilt some wine on the floor or sand on some concrete, that would make a really complex pattern, but you would not find another copy of that. It would be a one-off. So that would
Right.
just be completely natural.
Right.
So then, so that is kind of very interesting that you've got complex, high abundance objects that you can then count. And then I'm saying, what is the shortest path to get there. It needs to be below a certain number. To help you visualize that, for molecules on Earth, it's actually 15. So what do I mean? So if I took a coin and I flicked the coin and I got heads each time, 15 times in a row, that would be much harder than getting twice in a row. So let's say I flick it once, get heads, great, 50-50. I flick it again and get heads, great, 2 in a row, that's cool. Flick it again, I get heads, you're like 3 in a row, oh, I'm on a good run here. 4 in a row, 5 in a row, 6 in a row, 7 in a row, 8 in a row, 9, 10, 11, 12, 13, 14, 15. Each time you flick a heads and you have an equal chance of getting a tails, that's telling you something very statistical is happening, that biology is being involved or information. And that's the best way of looking at it. And that kind of statistical coin flipping argument helps you understand. And so with that argument, you can go and search for life in the universe without knowing anything about the life. You just look for objects that exist in high copy numbers that have many different parts.
And you take out the repeats, right?
You take out the repeats, yeah.
Man, that's a hell of a good way to explain it. Okay, so that's the lens from which you're looking for this stuff, right?
Mm-hmm. Yeah. And so for a number of years when I was developing this, all the different areas of science were kind of like telling me it wasn't interesting because it was obvious.
Yeah, trivial or something like that, yeah.
Yeah, and then everyone else was saying, this is impossible, it can't work. And so you had two sets of people saying it's obvious and it can't work. And they're like, well, okay, this maybe means we're on the right spot. So I think what happens is there's actually computationalists were kind of not annoyed, or arguing with me a little bit, because if you do if you compress information in a zip file, say, you can actually look for the number of repeats. But what assembly theory does is doesn't just look for the number of repeats; it draws a pathway to it, and so there is a path dependence in a zip file. The path dependence isn't exactly the same, and in fact, it's not really captured in the same way at all, which means
that's right.
You lose all that information.
Yeah, exactly. On old hard drives, the defragmentation would fill up things with like noise space. You know what I mean? Mm-hmm. That's kind of similar. Anyway, let me check and see if we got any callers just to make sure. I don't want to ignore anybody here. We do have Aaron. So Aaron's one of my buddies. He has a lot of good questions. So let's get him in here, and we will talk more because I want to. I mean, if we can talk about a lot of other things, but let's get Aaron in here and see if he's got something good to change.
Okay, cool.
All right, Aaron, you are on with me and Lee.
Hello, Lee. It's nice to meet you, sir. I respect everything you do, and I wish I was more like you. But anyway, so when I think of life in the universe outside of Earth, there's one thing that I always come back to, and it's this idea of probability. Now, I understand that math doesn't dictate the universe, it only explains it. But and you said earlier that it's generally accepted that the periodic table of elements is pretty universal. Well, I would even go a step further back than that and go, if we take everything that exists and break it down to the point where you can no longer ask the question, what is it made of? And we start there as a base. And then we start asking the question, how many different variations of combinations of this particular, whatever you want to call it, be it a quark, be it something smaller than that, whatever it is, how many different variations of this one thing can you have? If there are only so many variations that you can have of whatever that is, that's a limit. And that limit means, given enough time and enough space, you're going to have repeats of that. That's how I know numbers to work. Now, I might be wrong about that. And so because of that, by sheer probability, not only do I believe that there are other, and there are going to be different, obviously, because they're not, the conditions probably aren't going to be exactly the same as they are here on Earth, like we said earlier. But what that means to me is, given how many other stars there are, given how many other galaxies there are, and given how many other planets there are in the universe, it is almost mathematically impossible for there to not be at least one other planet that has the exact same setup, with the exact same distance, the exact same size, and at least the exact same amount of water to land
Yeah.
ratio as the Earth.
Throw a question at him, bud.
So the question I have for you is, what do you think about that? By
Okay.
sheer probability, it's almost impossible for there not to be life on other planets.
Okay.
So Aaron, first, thanks for that. That's really a good point. Let me break it down a little bit because I think it's super interesting, and I don't disagree. But let's clarify a couple of things. So when you talk about probability, with quarks and things. So the nice thing about physics and most of the variables in physics, although physics can do many great things, statistics rules. So their probability rules really well. So we know lots about matter, and we think we understand how we can get to atoms and elements, right? To elements of a certain type, of atoms of a certain type.
Yeah.
So that's great. So I could complete, and that's what physics does very well, and that can just be universal. I'm pretty sure over the entire universe, you can make the same kind of materials. So that's great. Now your point is like, because there's so many chances, that there should be, by that argument, there should be other Earth-like worlds. I think that's one way of looking at it, but I'll give you even more reason to say that. So I would say that that's great. You're kind of saying it almost similar to what we have on Earth, but I would say there's even more chance than life just being, if life isn't constrained to Earth just on those numbers, because there's no evidence that life needs precisely the amount of water or precisely the ratio of elements. I think that it's like saying, there's a very special star like our star, and it needs to have that precise amount of hydrogen. You'll get that star. Actually, you get stars that cluster into certain classes as a function of size and their energy dissipation. The actual number of variables controlling the star is quite low. So I think that when it comes to probability, probability is even greater on your side. So there are so many exoplanets, there's so much chemistry going on, and because we don't need, and this is the critical thing where I think there might be not a divergence, but a clarification from your point. I would say, because we don't need to follow the exact path we followed on Earth, that there's even more chance statistically that we're going to get to an evolutionary paradigm in these different planets. So I don't
Sure.
think
Yeah.
we need to have an identical pathway, because that is so hard, right? Because every time you get to a decision, there's a branch in the graph, and before you know it, the branches in the graph, and get this, the branches in the graph exceed the number of states in the universe. And when the number of states exceed, then you're like, there can be only one off. So that's a really cool thing, right? So if you can estimate the size of the universe and the size of the states available, and when your number of decisions made exceeds that, you're absolutely unique. But then all you have to do is go down the graph and say, well, I don't need to be, these decisions are arbitrary. They're not really affecting anything. So you go down the graph. And so what you can probably say is, yeah, I would ask, if I were you, and say, on the basis of probability, what is the worst case scenario and the best case scenario for finding life in the universe? And the basis of probability, I'm very excited, and I would agree with you on that. And I would just so I'm just trying to say that it doesn't need to be identical, because there's no other Earth in the universe. There's no parallel universe with Earth. Earth is entirely unique, but there are lots of Earth-like, almost Earths in the universe, and there's a spectrum from and the interesting thing is, what percentage of those spectrum of those planets are all alive? And Earth was quite dumb. Earth's IQ was quite low until, and that's not us. I mean, we probably should talk about IQ. It's very, but Earth became, with mammals and then humans, quite late. And I actually wonder if that was because the gravitational force was quite high, and it took ages for biology to basically work out how to use oxygen properly so we can move around, and our brains are quite energy intensive. If the gravitational force on Earth was lower, could we have got to consciousness or intelligence a few billion years quicker because
Maybe.
we didn't have to learn how to do all this extra chemistry. So when there might be that, and I don't know. We can use this. I won't use the R word. I would just say Earth might have been slower in its development and consciousness than some others. So I don't know if that makes sense, Aaron.
Aaron, you still with us?
I think he's dropped off.
Oh, he accidentally. That's okay. I know. I understood exactly what you said, and I think that was a brilliant answer. We have one of our other friends, Tree, here. He's a new member of our community, and we're gonna hop him in. Okay,
Yep.
Tree, what's up, man? How's it going? Can you hear me, Tree? Testing, testing, 1, 2. Okay. We're gonna give you a few more chances here. Tree, are you there?
Maybe
All
he's
right,
not.
we're going to the next. Oh,
No, that was me. Sorry.
oh, that was you. Okay. All right, Tree, I'm gonna drop you back down to listeners, bud. You can jump right back in the caller queue, and I'm gonna invite Nivik to speak. Okay. Nivik is another one of our friends on the Pangburn Hangout, Lee.
Hello, Nivet.
Hello, Lee. Since you mentioned not wanting to talk about IQ, made me want to talk about IQ. Um, I wanted to know your thoughts. Well, number one thing I was interested in was CRISPR tech, and
Oh yeah.
what are your hopes that you think that could bring, and that that's beneficial, and your view of IQ, and the thing about it, it could be controversial because who's to say what is smart, right? What is intelligence? It could be hard to say. What you Sometimes people have a bias. It's like what I do is intelligent, and what the other person does that's different. That is not intelligent.
Yeah. So
And
Nivik, let him answer your first question, buddy.
What was the first one again? About CRISPR.
CRISPR. Yeah, CRISPR.
I
Yeah.
don't know. I don't really have. Yeah, I hope CRISPR can be used to help. Well, I don't know much about CRISPR until I don't practice CRISPR in the lab, right? So,
Yeah.
when it comes to gene editing, I mean, I hope that CRISPR will be able to be used to cure disease, understand biology, create new technologies. Um, I'm not sure how I feel about altering humans' germline in general. I guess that might happen, but again, I don't know enough. I mean, uh, a friend of mine, who I haven't spoken to for ages, actually, George Church at Harvard, kind of has very strong views about that. How CRISPR can be used. Um, I don't have much other than I hope it can be used to. I mean, it'd be great if we could use it to drop our healthcare costs in general, right?
Yeah. Yeah.
is it
Uh,
Yeah.
true? Is it true that you can grow brain cells, or is that just because every now and then I hear that you have a fixed amount, and that's not the case?
Well,
oh
there are
no,
about
no.
a
I mean,
hundred billion.
I was wondering
in
about your
your
Yeah.
no,
understanding.
no. That's a slightly different question. In your brain, yeah, sure. You have. It's possible that you can grow you grow new brain cells to replace old ones. I don't know that. I don't know. It's just quite hard to do the experiment, right? Because who wants to go into their brain and count the number of cells they've got differentiating? There certainly is evidence that you can have neural regeneration, right? When you've got so this whole idea that your brain can't repair itself is actually not correct, because when people have
Yeah.
strokes, they get better.
Yeah.
But I just don't know. I mean, CRISPR, I'm building chemical computers that will do CRISPR in the end. I really haven't got into that yet. I'm waiting for the technology to mature so I can view it. All I know is what's happened in the past few years, particularly with RNA technology, is that we've come a long way to be able to get cells to generate new protein, okay, on demand. I mean, the COVID-19 example was good at that. So my hope for CRISPR is that it becomes a useful technology, and that it will transform, the experience of quality of life of people on Earth, and that
Yeah.
we use it ethically, and maybe we think carefully about doing things that are against evolutionary principles.
I
Hmm.
believe the COVID CRISPR, wasn't it?
Hang on, Niv. Hang on, Niv. Let him finish, bud.
Yeah, I was going to say, because if you start to improve, you try and make improvements on the embryos and things or human beings, there might be there might be unforeseen consequences. And I think, we have to work out how to regulate that globally, not just, there's this guy in China who decided to do CRISPR on a couple of embryos to stop them from getting HIV. And I think he's now in prison. And also he caused these babies to actually have more, quite important problems, right? That was pretty dangerous.
They don't care too much about the ethics of CRISPR in China, I don't think, do they?
Oh no, I don't think that's correct to say that. I think that China is in a desperate race to catch up on IP,
Ah,
and when you're catching up on, and also that culture's so different that it's very easy for us to kind of demonize, but Chinese people and American people and British people and French people and Germany are all the same.
yeah,
We all respond to incentives. And the interesting thing about China is that we could spend ages talking about it, is just where the population is different. So the way you control people in the population and the political system is just a bit different, right? So I think it's very difficult for me to overcome some of my kind of tribal, like, yes, those damn Chinese, or those
no, I hope I didn't make that to any Chinese people listening. I swear,
no,
you're not unethical. I watched
no.
John Oliver one time about CRISPR, and they interviewed a Chinese scientist and they asked them the ethical implications, and he basically said, "Not a problem." So that's just one little data point that
Yeah,
I
yeah,
was.
yeah. I think, I mean, the ethics are different in China because Chinese. Well, it's not the test is on improving the population rather than worrying about the individual. So this is with GMO, with genetically modified foods, right? Arguably, genetically modified rice has kept hundreds of millions of people, if not billions of people, from starvation. Whereas in Europe, we still like, oh, is it safe? And China's just gone, screw it,
Yeah,
you know.
yeah,
Here we
yeah.
go.
Just go straight through. Yeah.
But
Um,
so the next
One more
one for
question.
yeah,
go on.
Nivek, we're gonna get one more question from you, but let Dr. Cronin finish.
Yeah, I was just going to finish your IQ question, right? So my answer to the IQ question is IQ is a test of your socioeconomic status and a little bit of your ability to learn, but not much else.
Yeah.
Oh,
That we actually, real quick, Nivik, I interviewed Dr. Scott Barry Kaufman, and he's studying intelligence, and he said it's hard to get away from the G factor. General intelligence on all these IQ tests seems to point, all roads seem to lead to this G factor, unless we're talking about like intrapersonal intelligence, musical intelligence, all these theories of different intelligences. But if you ever get the chance, Dr. Cronin or Lee, go listen to that episode because I loved it. It was a great talk with him. It was last week. But Nivik, go ahead and throw your second question out, and then I'm going to try to get Tree back in here. Okay?
no, I just wanted to extend on your IQ. With the nature nurture, do you believe it's fixed? In how some people view it, in where what you have, that's pretty much it, or do you think you can actually grow your IQ, and in there since there's so little to learn about the brain, you think that there could be a potential there, in where you could grow, you can grow it. I'm guessing by nurture, but I mean nurture can be nature as well, because how you eat and how you take care of yourself, in nutrition and the environment that you're in.
So
It's
what's
not
what's the
hard.
question, Niv?
If you no, the question was if he thinks that it's fixed or it could potentially be grown. Because some people have two views of it. Some people believe, well, whatever it is, you can only go so far to your potential, but then again, you know what I mean. Maybe you could actually grow your IQ. Do you think if it's your IQ, it would only be fixed, or you think that you could actually learn more, taking more knowledge, more
There you
permutation,
go.
more logic in
Yeah.
order to grow your intellect?
Okay.
Okay, that's it.
So I think so. There's this very simple way to look at that. I mean, I don't really have much in the way. So thanks for the question. Right, it's a good one. I don't really do much belief because belief is just belief, right? But I can tell you what seems logical. Um, I think that your capabilities, everyone has basically similar cognitive intelligence capabilities, right? There are obviously some spectrum of them, but I don't know how to measure that. But I think that an individual can always improve their ability to solve problems by learning. And actually, it comes out of your attitude to learning is probably more important than your brain, whatever your genetics in your brain, right? So I think so for me, I mean, I was in special school, right, for people that had learning difficulties because I couldn't read or write or do mathematics for many years when I was at school. But I kept asking the question, why? For me, why was a great question because it was a great way of phrasing the question to everything. Why does that work? Why? How's that? Why is that? And that curiosity kind of kept me learning. And so I think it's very possible for people to be incorrectly classified younger as being low achievers or high achievers. And I think that's actually counterproductive. I think we're going to find in the future that most human beings are capable of reaching the same heights as Einstein and Feynman and so on. And it's actually really about, your personal preferences, right? So I would say it's it's not almost trivial to improve your intelligence if you mean problem solving skills by learning and trying to learn and dedicating time to it. That's the first point. The second point, though, is when you get older, the reason it's easier to learn new things when you're younger is like the tank is not full, right?
Yeah,
You're just kind of like filling up the tank.
yeah.
So what you've got to be able to do is almost be really good at forgetting things and trying new things when you get older,
That's actually a great idea.
without having dementia or loss of cognitive function. It's this ability to try new things and also not being flexible. And that
Yeah,
older people, it's said that older people can't learn. I don't think that's right. I think that older people have just experienced so much in their life that works for them, and those evolutionarily those neurons are going to be reinforced quite greatly. It's quite difficult to remove those things unless you ask radically different questions. So, to answer your question, do I think that people's intelligence can be grown as they grow? Sure. I think it's the overriding example show that nobody is limited in that. There's nobody unless you've had an accident or you're grown with a certain genetic defect. So I think everyone can do that. I think the trick, though, is you to put yourself into different environments. Because you imagine in evolution, this is what you did. If you find yourself in a rainforest one day, on a desert the next, or in the ocean, you've got different problems to solve. And those different problems to solve kick in your entire system, your body, your hormones, your stress hormones, the way that you're
yeah,
thinking, running, fight or
yeah,
flight, and this and this. So whether you're in a meditative state or a stress state or a sleeping state or a hibernating state, changing those states whilst asking why, I'm guessing, and I'm no cognitive psychologist, I'm just a chemist, right? We build robots. But my experience is that I don't think there's an effective barrier for improving your intelligence if you measure that by your ability to solve problems. But you have to be motivated. So I think the key things are motivation, curiosity, and the ability to be in different environments. And then the final thing to just be able to willing to commit time to do it.
yeah.
Those four things,
The
everything
the
is.
willpower and the critical thinking, right?
Yeah. And I think I used to incorrectly, when I was younger, think that old people were just inflexible and just didn't have new ideas. I mean, there's totally bullshit. And then as I got older, I realized that I knew a lot of young old people, and that I was pretty special in the regard that I don't have any beliefs. As soon as I'm proven wrong with the data, I'm like, oh shit, okay, I'll adopt this.
Yes, that's so good. I agree with you entirely. The wise man apportions his beliefs to the evidence. David
Yeah.
Hume. Nivik, we love you. Thank you for coming in. We're going to take Tree on and try this one more time, Tree. Tree, you're on with us, brother. How are you? Did we get you this time? You got to unmute, my friend.
Hey,
Hey, what's up?
not much though. Thanks for having me on.
Yeah, you're welcome.
I was wondering, it's really, really interesting what you're talking about, especially about assembly theory. And I was wondering, do you believe that there's a kind of a limit on the number of structures that are possible, that would cross your threshold for complexity to say, well, this could be life on that basis?
Yeah, I mean, so what kind of amplify that? So what you mean that I will just detecting life just on complexity alone? Yeah.
Yeah, like I mean, just to say, for example, a lot of the like all the life on Earth is carbon based, right? And it's because their carbon has specific properties that make it like it's stable, but it also has like what is it? I think it's like four different uh bonds it's possible, right?
Mm-hmm.
So are there like structures that like lend itself really well to passing your threshold in assembly theory, or do you think like it's just it's kind of like any element could be part of it, or any element could be the center of it? It's just a question of how big is it, I guess, right?
So yeah, there's two answers to that. So I think that carbon is pretty good on Earth because it can have lots of different connections. So on Earth, the pressure and the temperature we have, carbon is good. But on Venus or somewhere else on Jupiter, that may be different. So, but I do think that having been able to have lots of different connections increases your ability to get to complexity quicker, and so that will be a factor. Does that mean that all life in the universe is just restricted to carbon? I don't know. I wouldn't think so. But given that could all life in the universe have to go through a carbon stage? That might be possible. And it might be that, will life on Earth always be based on carbon? I don't think so. I think we might actually outgrow carbon at some point. It's going to be hard to outgrow evolution and all that other stuff that we've learned, right? So we might always keep human beings as pets. When we go to silicon, robotics, whatever. But I don't know. And my views on that change almost daily. Because the thing is, I would have to really conceive of, if you basically just pin me down and said, okay, life forms based on other elements other than carbon. What would it look like? How would it work? Silicon is an obvious example. Phosphorus might be a good example because phosphorus can make lots of bonds. But I'd have to look at the planetary environment because it's not just the intrinsic capability of the element of those bonds, it's the conditions under which they're stable. And so all our chemistry is biased by one atmosphere pressure and the boiling range of water from freezing and boiling, which is quite convenient at that pressure. So I think there should be other ways to get there, but it's hard to conceive of. I agree.
Like, would you say, like, say, it's unlikely that, say, something that's very stable, like, I don't know, like a noble gas or something, is likely to be involved in one of these structures?
Hard, because the noble gases to become reactive, you'd have to put them under enormous pressure. And then for life, really, you need some kind of ability to do cognition. And if you're under such a much pressure, if the amount of energy you need to move around is beyond a certain maximum, then you might not be able to do very much. But that doesn't, I don't know, exclude that a high pressure environment might make something work. I don't know. In the Hail Mary, they were using xenon, right?
Yeah.
But that was kind of fantastical chemistry that doesn't necessarily possible. But it is possible to get noble gases to react. It's just hard work. Um, I don't know. I don't know. To be honest with you, what I'm trying to do right now is I think that if I was to make a guess, I would say most life in the universe is that's chemistry emerges in chemistry. It's probably based on carbon. But what are the features of the molecules in carbon life in the universe? It can be radically different.
Go ahead, Tree.
And would you say that it's unlikely that there's anything say smaller than chemistry? Like some life existing at the quantum level, given how, like, I mean, I don't know so a huge amount about quantum physics, but it seems quite unstable. Like it'd be difficult for,
like an electron or something being conscious. Is that what you're talking about? Or
yeah, like, or I don't know. I mean, this is something at that level. Like, it seems like chemistry would have to be the basic level of life would exist, right?
well,
Yeah,
there is
so
quantum chemistry.
yeah, no, so all chemistry is quantum, right? So I think that what you're saying is, what is the size range at which lifelike characteristics are manifest? So I would say
Exactly.
really for that, it seems that most between the virus capsid and the cell. So even it has to go beyond molecules. You need to have a collection of molecules in a container, and that
Pass.
seems to be between the virus capsid size and the, uh, uh, the 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 cell.
There was do you have like an idea or a way you imagine that assembly theory would be used to identify life? Do you see it like, we spot something with a radio telescope, or do we actually have to physically interact with it before we be able to understand if what we're looking at is life?
I'm sorry, say that again.
One
So
more time, Tree.
yeah, do you imagine like that assembly theory could be used to identify life from like a great distance, or do you think we'd have to get a lot of detail to understand if this isn't life using that theory?
Yeah, great question. I'm just about to publish a paper, a preprint, that shows you can use infrared spectroscopy to detect complexity of molecules. So, in principle, if we might be able to start to infer life on other exoplanets. It's going to be hard because you're going to have to do quite a lot of modeling, but in
Mm-hmm.
principle, it's possible. And it's a really good question. So, assembly theory right now in the lab, I've used some techniques. So, a technique that weighs molecules and cuts them up called mass spectrometry, a technique which is like MRI, but for molecules. So, we can count the number of different atoms in it, and then infrared, which is basically allows the molecule as you heat it up has a characteristic glow, a bit like if you put a coal in a fire, grows red hot. You put a molecule into some energy, it gives off characteristic light, and that light you can use assembly theory to work out if the molecule's above the threshold or not.
And like, wouldn't that require like a huge amount of molecules for that to be like visible from such a great distance, right?
Oh yeah. I'm actually thinking about designing a molecule that we could make several billion tons, right? A really complex molecule that absorbs in the infrared. And if humanity is about to go extinct, we just eject this molecule into the atmosphere so aliens knew we were here, like an emergency,
Wow.
like an
Yeah, nice.
like an emergency beacon.
That would work though if they were anywhere as near as advanced as we were. If
Yeah,
they were
yeah, yeah. I
looking
mean, if
right
you had a
away.
planet that basically was like that had some binary code in the gas, that would be the ultimate biosignature or
Oh
death
yeah, like
signature.
yeah,
Yeah,
yeah, that would be like the binary code of the gas or something. Yeah.
yeah.
Tree, your questions are amazing. Can you call back in so I can get Salman in for a minute, and then you can come back on and ask some more.
Sure.
Okay. All right. Salman is one of my best friends in the world, Lee. So I expect good things here. A brilliant, brilliant person.
Hello, can you hear me?
Hello.
Yes, I can hear you.
Okay. I'm sorry, by the way, I have just 2% on my chart, so I'll try to be quick. Dr. Lee, I was wondering if you think that the assembly theory could be applied potentially beyond just chemical molecules, right, on any object. Meaning, I'm just thinking like, could there be like a situation where we have complexity emerging in nature that is not necessarily evidence of information processing? Like, it could be just embedded in the rules and the laws of physics itself. I'm thinking something like, the game of life from simulations, and simple rules could produce very complex outcomes in the long run, like something like galaxies in our universe.
No,
They may fit the criteria for like assembly theory, but are they
they don't.
necessarily
They don't.
evidence of life?
They don't. So assembly theory says two things. You have to have a copy number in abundance. So what you need to do is your complex object needs to exist in identical You need to have an abundance of identical copies. So the word complexity is misused. There is no complexity in the universe except for life. When you see a storm on Jupiter or different galaxies, these are complicated. These are complex because they've got lots of individual features, but they are one-offs, right? So until you find an identical copy of an object, it has no assembly. So the assembly equation is a function of the number of identical objects and the assembly index of that object. So let me give you an example. There's a difference between finding, let's say I write a book with random letters, right? This is equivalent to you looking up in the sky and seeing lots of different galaxies. But if I write a book with phrases in it and those phrases have repeats, right? So you can see those words repeated all over, then you know that it was created with some information. And that's super important. And lots of people fall into that trap and say, oh, I can think of an instance of seeing something complex. But yeah, sure, the more complex it is, the more one-off. And so, and that's really the important point.
That makes sense. Like it's very difficult, I imagine, to have identical galaxies in every way, right?
Exactly. And if you find identical galaxies, you're in a simulation, or there's some life form that is the size of a galaxy, which would be unlikely.
Yeah, this is
That
the
makes sense.
Leibniz's. Go ahead, Salman.
Yeah. Thank you, doctor.
Love you, Salman.
Love you.
Bye. All right, we got Aaron again. Aaron, I'm sorry. I'm just playing with you. What you got? What you got, Aaron?
So I didn't realize we'd have more than one opportunity to speak. It is brilliant.
Oh yeah, I mean, as long as real quick before you start, Aaron. How much longer do we have you for, Lee?
10 minutes.
Okay, go ahead, Aaron. Give us a good one to end on.
So, full disclosure, this is purely a theory of mine, and it's not based on any particularly concrete evidence. But when we're talking about consciousness, I have a proposal that says that I believe that everything that lives has some level of consciousness, and that consciousness is almost as inevitable as gravity. Like if an object has mass, it has gravity. I say that if something has life, it has consciousness. And the best thing I can point to is some of the behaviors of other animals. For instance, there's an entire group of animals that, having never seen themselves before, having only lived in the wild, could recognize themselves in a mirror. There's a species of bird, there are certain types of elephants, there are even certain sea creatures that could recognize themselves. And I go a step further and say, think about predator/prey. There has to be some level, and again, this is purely theoretical, there has to be some level of knowing that whatever you're chasing or whatever's chasing you isn't one of you in order to know that you have to escape it. I don't think it's quite as automatic as there's something chasing me, let me run. I think that there is embedded in all living things the notion, a sense of, I am something, what that thing is not me, therefore it must pose a threat. What do you think about that?
Yeah, let him get in there.
So I think consciousness is so that you might be calling something conscious, which I wouldn't call consciousness. But yeah, I think I understand what you're saying. I think that consciousness isn't. I'm not a panpsychist. I don't think that everything has some consciousness, and I don't think all life forms are conscious. But all life forms have some mechanism of awareness. Even a bacterial cell can detect other bacteria, and so what we're kind of talking about here is a labeling scheme. So the problem with consciousness, because we don't know how to define it correctly, we get muddled here. So, but when you're talking about the automatic response of some animals, no, they don't know. They don't know what they're chasing, and they don't know. I mean, and actually, the classic female-male spider, and when after they've mated, the female spider eats the male. She doesn't know she's eating the male. She's just programmed to do it.
Yeah.
It's kind of hilarious to do. So there is a higher ordnance emergence that comes with, and I would say all animals probably have some degree of awareness, and I think awareness graduates into consciousness. Let's say dogs are conscious, I would say, right? So, but
Yeah.
then above that, there is a degree of abstraction where you can count and have language. So you might have awareness, consciousness, if you like, or becoming conscious, and then abstraction. The ability to abstract is even above consciousness. So I might be with you in that
Yeah.
the bridge between awareness and abstraction is consciousness. I don't know if you find that helpful.
I think I just real quick, I tend to agree that that abstraction, you have to be able to abstract that you have that you have a state of consciousness. Is that kind of what you're saying?
Yeah,
Okay.
exactly.
Okay. Aaron,
That's
do you
fair.
want to ask one real quick question and then let's let Dr.
Yes,
Cronin go because he's been
just
really helpful.
one last thing, and I want to say thank you for your time. I've learned a lot from you. The last question I would ask is: would you say that there's an element of the more complex the life form gets, the more complex the consciousness becomes? Because I think that that would accurately explain why a cat maybe isn't quite as conscious as a human being or not as self-aware.
I don't know.
Yeah. Go ahead. I'm
Yeah,
sorry.
no, I think it's certainly a cat. Some cats seem that they don't have anything, and other cats do. Dogs are definitely all aware. I don't know if it's just about complexity. It's probably as simple as connectivity in the brain. And I think that probably the dogs are on the cusp, and chimpanzees and human beings. So I think that if I don't know if whales and dolphins are hyper intelligent, but they do have a huge brain and a huge amount of connectivity. And because we can't communicate with them, they probably don't have abstraction ability. So I think there is some correlation with number of connections. You might call that complexity, but I think that once you've got to a critical amount, then it just works. It's a bit like
Yeah.
when you have enough hydrogen to make a fusion reaction self-sustain in the start. It's just undergoing fusion. You're in that state.
Yeah.
So I think there is a critical minimum that you can get to.
Yeah.
Understood. Thank you.
Aaron, thank you for the awesome questions. I guess we'll let you go now. Thank you so much for coming, man. I love talking to you. I love learning from you. You seem to be along the same lines scientifically as me, and I love talking to people who are like that. If you ever want to come back, please do so. I would love to
Okay,
have you back
don't
again.
worry. It
And
was great to
yeah,
come by, and sorry I have to drop off pretty much on the
no,
dot. It's just actually forgot that I'm speaking to a friend at SFI at Santa Fe Institute, and I was one of the reasons I asked someone to repeat a question. I had to quickly email them and say, no, I'm stuck. I'm finishing something.
thank you.
So because I penciled in 90 minutes to do this, and it was a pleasure to do so. So no
Well,
problem.
we love you, man, and I really appreciate it. And I
Yeah,
wish you all the best of luck, and hopefully we'll see you again.
yeah. Thanks for having me on, guys. See you later.
Thank you, brother. Have a good one.
Yeah. Bye.
All right, guys. What did you think about that? That was fantastic. Tree, I'll get you up here to speak. Hang on just a second. That was fantastic. Dr. Lee, if you're having trouble leaving, it's in the bottom right corner. Uh, but you can stay and listen to it if you want to. Scott, are you with us? Hello, Scott. All right. Jack, are you with us? Nobody's here but me and Tree. Oh, what's up, Tree?
Yeah, I really, really enjoyed that idea, especially when at the end where he's saying the idea of like a critical mass for